Good evening everyone. Welcome to Gradeup. Welcome to the session Startup Series 2021. So I can see already few students are waiting. Vijay, Madesh. Good evening everyone. So students, those who joined the session, please mark your presence. Vijay, you need Gradeup iOS app. I can say only one thing, it's under construction, under development. Priya, good evening. Rahul, good evening. Shiva, good evening. Santanupatra, good evening. Good. Dibyendru Chatterjee, good evening. Amit, Uday, Entertainment Knowledge Mania. Hi. Yeah guys. Hi everybody again and welcome to the session. Let's get into the session. Today we will be discussing about the instruction formats as well as addressing modes. So it's continuation to the previous class. In the last class we have discussed about the types of instructions. What are different types of instructions, guys? We have discussed. It is classified into based on two factors. One is based on ALU operation. It is classified into data manipulation, data transfer, and program control. Right. And there is another classification. What is that? Based on reference for IO values. In the last class, we have covered this. Based on the operation ALU perform, how instructions are classified. The other is based on reference for IO values. Let's go with this. So based on the reference for IO values, what it means to understand this, please have a look at these three snippets of code. Everybody, just have a look at these three snippets of code once. These three are for adding two numbers, A and B. These three are the snippets of code for the simple addition, right? Assume the C programming language statements these are. What's the difference you find between these three? If you see in the first snippet of code, A value and B value I am initializing, I am adding A and B and putting that result in C, right? Even in the third snippet of code also same I am doing, putting the result in C. But in the second snippet of code, if you observe, I am not initializing A value and B value, I have just declared them. Using scanf, I will give the input for A as 5, enter. I will give the input for B as 7, enter. Then I will get the output 12. Isn't it? So same inputs, same outputs, values are not changed. But what's the difference you find? Here for A and B and C, whatever the memory that you imagine, maybe like 2 bytes or 4 bytes based on the processor, this will be for A, B and C, memory is allocated where? In the RAM. That means you can say the 2 bytes or 4 bytes allocated in memory. But when I use the register storage class, the same 2 or 4 bytes for A, B, C each allocated where? In CPU registers, isn't it? In CPU registers. Here where A and B values are getting stored, they are not getting stored anywhere, right? So please observe, at runtime, you know the meaning of runtime. While execution, who is giving the input? Who is giving the input for ALU? A value, B values are supplied by whom? To ALU. To ALU. Memory is giving the input, isn't it? Here who is giving? User is giving the input, right? And here who is giving? ALU is taking the input from where? CPU registers, right? Similarly, here where the output is going, the result is stored where? In C. Where C is in? Memory again. Here where the output is going, it is displaying on the output screen. That means user is directly getting the output. And here where the output is going? To C. Where C is? In the CPU registers. So by this time you could understand what it is. For the inputs or for the outputs, whom ALU refer? From where ALU take the input to where ALU produce the output. Based on this, instructions are classified into memory reference instructions, register reference instructions, IO reference instructions. Why? User will give the input through input device, user get the output through output device. So IO devices are the interface between us and computer. So IO or user you can use interchangeably. So you may call it as user reference, nothing wrong, but formerly we will take them as IO reference. So here what instructions are in memory reference, sir? What instructions are register reference means there is no such a particular instruction to say that it is a memory reference or it is IO reference. Why? What is the parameter for classification here? From where inputs are coming to where outputs are going. So guys, if the operands are memory operands, memory operand means address. I repeat, memory operand means how do you specify about an operand in the memory? You will give its address. So if the operand is the memory operand, then you can say that instruction is memory reference. If the operand is the value, you can say that is IO reference instruction. If the operands in the instructions are register names like R1, R2, R3 or A, B, C, you can say them as register reference instructions. So add can be memory reference, register reference. Load can be memory reference or register reference, IO reference. So there is no such particular instruction or opcode to say that it is register reference, it is IO reference, because you should see the operands. Based on the operands, if they are memory operands, memory reference. If they are values, IO reference. If they are register names, register reference. Very simple. So the second classification for instructions is based on reference for IO values, memory reference, register reference, IO reference. Guys, could you please prove that you are not sleeping? I am really surprised no one is giving any comment. Guys, hello, are you there? Could you please respond? Oh, I have to wait. It's very fishy, doubtful. No response, guys. Any problem? Okay, you are all here. You are all here, fine. Did you get this concept? Did you get this concept, guys? Yeah, hello everybody for the new joinees for the today's session. New joinees or late joinees, right? Okay, fine. Now, types of instruction formats. What is a type of instruction format? First, if you observe, what is the basic format of an instruction? What an instruction will be and how it will be looking like? There will be opcode and there will be information about operands, isn't it? This is the basic structure of any instruction, right? This is the basic structure of any instruction. Now comes a simple doubt, and it's not simple if you think. That's very big doubt, worthy doubt. What is that? Sir, you have written operands information. This S is disturbing us a lot, sir. Why? When you use the term plural, there is big range of possibility. So, how many operands can be represented here? How many operands can be represented? Right? How many can be represented? 1, 2, 3, 4, 6, 8, isn't it? So, this doubt definitely should come. So, this becomes the parameter for the classification of, instruction formats. So, what is the parameter? Based on number of operands that can be specified, that can be referenced, specified in an instruction. So, in one instruction, how many operands information can be given at a time? Based on this, instruction formats are classified. What are they? Let's see. What are they? Three address instruction format. That means you consider some opcode with 3 operands: OP1, OP2, OP3. 3 operands, provided these 3 should be memory operands. These 3 should be memory operands or register operands. They can be either memory operands or register operands. That means in these operands field you may write either address or you may write the name of the register. Then that is called 3 address format. Here address means not memory address, guys. Here the address means reference. Here the address indicates that it is a reference. Okay? And next one is 2 address format. Before that, when 3 addresses are given, 3 operands are given, then the first one is considered as destination operand. The next 2 are considered as source operands. When 3 addresses are mentioned, first is destination, second is source. The next 2 are source. Okay? And the next is 2 address format. That means followed by opcode you will have 2 operands. These operands also can be either memory operands or register operands. Either or, not both. You can't take mix. Like one memory operand, one register operand is not allowed. Either memory operand or register operand is only allowed. Whenever this is the case, the first one is considered as destination until operation is over. Until the operation is completed, the first one is considered as destination. Once the operand is, and the second one is of course, wait a minute. I have just written it in wrong way. Until operation is completed, both are considered as sources. Once the operation is completed, the first one is considered as destination. For example, I is equal to I plus j. You might have seen this kind of statement many times, right? I is the source, input as well as output. So the first one is source until operation is completed, then it becomes the destination after operation is completed. Okay? Then one address format. What is one address format? Opcode followed by only one operand. Only one operand. So this becomes source as well as destination. Again the same. And this also can be either memory operand or register operand. Sir, one example. I plus plus. Mostly in the for loops you might have written this. So who is the source? I. Who is the destination? I only. Where is the other input? That's the constant, isn't it? Now, as this is just an increment operation, we say it's a unary operator. One operand is enough. But what if I write add R1? Like what is this? Increment R1. Increment R1 kind this is. So if the opcode is like INC, Yes, one operand is enough. What if the opcode is like add, but there is only one operand? This is a binary opcode, right? That means two operands are required. Then from where the second input will come? So one address instructions use one register, that is accumulator, as a default register. What is the register that is used by one address instructions? Accumulator. Its connection you will get in the operating systems at race condition problem also. At race condition problem, I will connect this one address format accumulator there. So for a while you can just understand, accumulator will be the default register for one address formats. And zero address format, that means only opcode. There are no operands. Then without operands, how an operation can be performed? Sir, could you give some example? Yes, why not? Push, pop, halt. Have you ever seen this kind of opcodes? Will there be any operand? No. That means whenever you use push, that is the input into the stack. What would be the input? What you enter? Value, right? Pop, value. Halt, which is a initiation by user. So guys, zero address formats, operands should be values. What should be the operands? Values should be the operands. And I have already said, if the operand is a value, what operand we call it as? Immediate operand. If the operand is a value, by default number is address. If you want it to be considered as value, what do you put? I as a suffix for the opcode, isn't it? So if the operand is the value, then which operand we call it as? Immediate operand, right? Then we have RISC instruction format, the last one. RISC instruction format. Here the operands will be only registers. The RISC supports only register operands like opcode followed by registers. Sir, how many? That is variable. There is no fixed number here. You can write multiple registers. So simply you can say RISC format supports. You can write as a note if you have not written already. RISC format supports only register operands. Zero address format supports only value operands. 3-to-1 address format support either memory operands or register operands. Now, based on this, you can say, will the length of instruction in RISC is fixed or variable? Tell me guys, length of instruction in RISC will be fixed or variable? Exactly. It would be variable. Why? Because how many operands will be there, that is not constant. You may write 1 register, 2 register, 3 register. Commonly similar operation will be happening on all. So the length of instruction will be definitely variable. So when this becomes RISC format, all the other becomes CISC formats. RISC supports only Nishant, it is not RISK. That RISC is different. You take anything here. INC, R1, R2, R3, R4, R5. So you want 5 values to be incremented. The similar operation to happen on all the registers at a time. So all registers values gets incremented. You need not to give multiple instructions. Have you ever written the array code? You need to retrieve array value. Let's say you need to multiply every existing value with 5 and store back. Have you ever written such code? So each time I gets change, isn't it? Each time I gets change. That means it's a different memory. That is a memory. But that you can relate here. If the field or space allocated for every array element is a register, you are doing a similar operation and you will be writing the similar single line for it. That is, A of I is equal to A of I into 5 in the programming. Similarly, when we want multiple values should undergo the same operation, then RISC is preferred. Yeah, RISC full form, Reduced Instruction Set Computer. Complex Instruction Set Computer. Okay. Now, let's get into gate problems. Fatavat. A machine has a 32-bit architecture with 1 word long instructions. It has 64 registers, each of which is 32 bits long. It needs to support 45 instructions, which have an immediate operand in addition to 2 register operands. Assume that immediate operand is an unsigned integer. That means only positive value. Then what is the maximum value of that? Have you read it? Yeah. So this is what the given information. Here what is 1 word means? When you use n-bit architecture, that n indicates 1 word, remember. However, that is given in the question. So here 1 word means what? 32 bits. Not every time. Not every time. 1 word means not every time 32 bits. As it is given, that is 32 bits. Okay. Now, so instruction length is 32 bits. Just now we have seen instruction format, right? We have seen instruction with 3 operands, 2 operands, 1 operand, no operand, many operands. We have seen. But have you got any instruction without opcode? No, right? So what is understood? Opcode is a mandatory field in any instruction that need not to be given. Remember, opcode becomes the mandatory field. So blindly you can write. Every instruction must and should have opcode. Okay. Each instruction has one immediate operand, two register operands. It is not given are they source or destination. So you can write in any order your wish. So I am taking the two register operands as R1, R2 and X be the immediate operand. Let X be the immediate operand. What is immediate operand means? Value. Okay. Now, how many registers are there in total? There are 64 registers. So every register should be identified uniquely. That means how many bits you should allocate for every register. If there are 2 power I registers, I bit address or I bit number you can give. Like if you have 2 bits with you, 0, 0, 0, 1, 1, 0, 1, 1. So you can give different numbers for 4. So if you have 3 bits to 8 registers you can give. So if you have I bits, 2 power I registers possible. So what is 2 power I? 64. So what is the I? 6. So every register will have 6-bit number. R1 will have 6-bit number, R2 will have 6-bit number. Now, every instruction will have what as mandatory? Opcode. So, based on number of instructions, number of opcodes can be understood. So, as it is given 45 instructions, you can understand there are 45 opcodes. So, if this is 2 power I, what is I? This 2 power I should be greater or equal, like you can say, with by taking which I value, this would be satisfied. 6 bits, right? Because if you get 5 bits, 2 power 5, 32 opcodes only you can. So minimum 6 bits are required. Now how many bits left for the immediate operand? Total 32, already 18 gone. So 14 bits left. So the number of bits left for immediate operand are 14. Now for n bit integer, in the programming you might have learned, if it is a signed integer, what is the range? Minus 2 raised to n minus 1, 2 plus 2 raised to n minus 1 minus 1. If it is a unsigned integer, what is the range? 0 to 2 raised to n minus 1. Isn't it? You might have learned it. So if it is a unsigned integer, it is given our immediate operand is an unsigned integer. And what is n? 14 bits. So what would be the range of this immediate operand? 0 to 2 power n minus 1, 0 to 16,383. So what is the answer for this? 16,383. Because you want what? The maximum value. Hi Akhil, thank you so much. Had your dinner, Akhil? You joined late comer, Mr. Akhil. Okay. So, did anyone has any problem with this? Just I have explored the problem and acquired the information. According to information, I tried allocating bits, right? Santanu Patra, you are studying in which year? What about others? Second year, good. So definitely you might have undergone the programming. So in the programming, at least the C programming language or Python or whatever, whenever you studied data types, you might have studied the range. If 2 bits are there, total 4 values are possible actually, but as the total are 4 values, you should give 2 to negative, 2 to positive. This is called signed. And if it is unsigned, all are positive. So you can say 0 to 3, isn't it? What are the possible values? 0, 1, 2, 3. So 0 to 3. So 0 to 2 power, how many bits? 2. 2 square minus 1. So that is how unsigned integer will have 0 to 2 power n minus 1. Right? And if your question is how I have considered it as unsigned integer, I have not assumed it. It is given in the question. Okay? Right. The next question. Consider a processor with 64 registers, an instruction set of size 12, and it's a 2016 gate question. Quickly go through the question, try to extract the information from the question, try to understand what is given, what you are supposed to find out. So first read the question, guys. You should read actively. Active reading is important. Yeah. So from this question, this is what the information that we can extract. There are total 64 registers. The instruction set is having the size 12. Each instruction is having 5 fields. Opcode, that is mandatory. 1 immediate operand. 2 source registers. 1 destination register, and then it is given the instructions are stored in byte aligned fashion, and there is a program which has 100 instructions. Total memory consumed by this program is. So this is the instruction. Now length of instruction is not given. But what fields are there in an instruction? We know opcode is mandatory field. One destination register, let me call it as RD. Two source registers are S1 or S2. Here SD means source destination, just for your simple identification. And one immediate operand, and that immediate operand width is given as 12 bit. The immediate operand width is given as 12 bits. That is given in the question. So it is a 12 bit. Now, as we solved the previous question, as there are 64 registers, every register require how many bits to identify uniquely? 6 bits. Whether it is a source or destination, there are total 64 registers. So every register requires 6-bit value. Then only you could be able to give unique number for every register, isn't it? Then opcode. For opcode, do we consider there are total 100 instructions? So 7 bits, or instruction set is having the size 12. So we will take 4 bits. This is always considered because instruction set has the opcodes. Using those opcodes you will write the program, means series of instructions. Or in the simplest way to tell you guys, CSE students, in our program we write for loop many times, printf many times, scanf many times, yes or no? So printf, anytime you write, any number of times you write, same syntax. So assume printf is like a opcode. So every time printf is identified with the same value. One time one value, other time other value will not be there, no? So always instruction set size is parameter for the opcode. This indicates number of instructions, number of opcodes. Okay? So how many bits? 4 bits. Now total, if you now count, what is the total length of instruction? 18 plus 12, 30 plus 4, 34 bits. So one instruction require 34 bits. And it is given every instruction is stored in byte aligned fashion. Shweta Pandey, listen please. What is byte aligned means? What is byte aligned means? Byte by byte allocation happens, and if one byte is not sufficient, second byte is allocated, and 2 bytes are not sufficient, third byte is allocated. So for this one instruction which is 34 bits, how many bytes should have been allocated? 5 bytes should be allocated, because 4 bytes 32 bits not sufficient. Yes, in that 40 bits 6 bits gets wasted, but that is what the meaning of byte aligned. Once the byte is aligned to one instruction, no other instruction can utilize that. Understood? So 5 bytes for every instruction. Now program has how many instructions? 100. So 100 instructions require how much memory? 100 multiplied by 5, 500 bytes. Yes, there is a wastage. There is a wastage, but the meaning of byte aligned is that once the byte is aligned to one instruction, it is always inclined towards that instruction. No other instruction can make use of it. So every instruction will acquire 5 bytes. Just this is the trick. This is what the point you should understand. The rest everything is simple. So what is the answer, guys? The total memory consumed by the program is 500 bytes. Okay. Next. This is a 2018 GATE question. Consider the following processor design characteristics. If not byte aligned, 34 into 100, 3400 bits, convert into bytes, that becomes 425 bytes. If it is not given as byte aligned, you can just say it's 425. As it is specifically given, it will be 500. Okay? Yeah. Look at this question and answer, please. Register to register arithmetic operations only. Fixed length format. Hardwired control unit. Of course, this I have not yet discussed, but RISC processor use register to register operations only. True or false? What do you say, guys? RISC operation use registers only. Is it true? Yes. RISC processor use fixed length format. Is it true? No. So if you have one only, then you will be in trouble because you don't know about this till now. Till now you don't know about this. But you observe the options. 2 should not be in the options. So you can just say what is the answer. 2 should not be in the options because RISC supports variable length. What is the answer? Yes, I know that you don't know about it, but still you can answer this question. One and 3 only. And guys, we will be discussing CU design, control unit design. There I will talk about CISC and RISC little more in detail. Okay? Right. Now, let's switch to addressing modes. Let's switch to addressing modes topic. What is addressing mode? This is what we say the way to express the information about operand. Or the way to present an operand. How do you present your operand? You may present it with its address, you may present it with its register, you may present it as a value. There are many ways to present. Like if you ask the same address to 4 persons, they will say the same address, but the way of expression would be different, isn't it? That way of expression is what we call as mode. So how do you represent your operand? That is called addressing mode. Simple. And what are types of addressing modes? Basically, there are 3 types of addressing modes. Don't be surprised. Basically, there are 3 types of addressing modes. What are they? Direct addressing mode, indirect addressing mode, immediate addressing mode. The addressing modes are broadly classified into 3 types: direct, indirect, immediate. Hemant. Hemant. Hi Hemant. How are you, man? Had your dinner? Like polymorphism. Yeah, exactly. Santanupatra, you are correct. Like how you can represent one, use one in many ways, in the same way. In the same way, you can represent any operand in many ways. So I need not to give many examples. Already our friend Santanupatra has just cleared all of your doubts with the term polymorphism. I am sir for you, I am son for my father, I am father for my son. So one in many ways. Simple. Yeah. So let us try to explore these addressing modes. First, direct or absolute addressing mode. What it is? Yeah, Hemant. What about your friends Gautam, Siddharth? Ask them also to join the session. Direct or absolute addressing mode, what it is? First, remember, it is also known as memory direct addressing mode or absolute addressing mode. Ready? Register addressing mode Leda sir. Okay, ready. You are from there. Okay. But in YouTube only English. Be conscious. It is there ready. It will come. Just hold on. So, direct or absolute addressing mode is also known as memory direct. Guys, quickly let me give you a simple clarity about this. Okay. Now, what is this? First of all, while you are analyzing the addressing mode, always be careful. Mind about source operands. What? Source operands. What we have to look at? The source operand. How the source operand is represented. Why, sir? Why you are not considering the destination? Because for every operation, we know every operation is done by ALU. And ALU has one default destination with it. That is accumulator. What is that? Accumulator. Any operation, you give increment, decrement, add, sub, and, or, not, any operation, guys. First, it will put it in the accumulator. Then do the operation. Result again stored in the accumulator. Then it will dispatch it out. So, there is one default. Though you give address, though you give register, you give anything, for ALU, only one destination, that is accumulator. Dois elephant. Please mind your language. It is an open platform. Please don't use such words. Okay? It's a gentle request, man. Okay. So, opcode followed by destination. Destination is least bothered for us. Now, source operands should be addresses. For the direct or absolute addressing mode, what should be the source operands? Addresses. Please make a note of it. For the direct or absolute addressing mode, the operands, which operands? Source operands should be memory operands. Only. Underline that only. No register operand, no value, no immediate operand. Provided, hold on, it's not over, such that the given address is having the value. Whatever the address you have represented, whatever the address that is given to ALU, at that address there should be value, then these are called direct addresses. What do you call them as? Direct addresses. So what's a direct address? An address which holds the value. An address which holds the operand. That is called direct address. Simple. Simple, right? So, an address which has value, that is direct. That address you are giving in the instruction. Who will receive this instruction? ALU. So, for the ALU, you are giving one address. At that address, there is a value. That is a direct addressing mode. Very simple. Then, indirect addressing modes. Guys, these are subclassified into 8 types. How many indirect addressing modes are there? 8 indirect addressing modes are there. What are they? Let's see. First is memory indirect addressing mode. What is the first indirect addressing mode? Memory indirect addressing mode. Example. Yes, you want example, I know. I am giving the example. Forget about opcode and destination, because we should look at source. You should zoom at source. Let's say you have written operands as A1 and A5. What A1, A5? So you can understand. Even for memory indirect also, the operands should be memory operands, means only addresses. Guys, the name will not be given just like that. There will be a reason. Only for human beings, names will be assigned just like that, just based on their wish. Right? Based on our parents' wish, based on our grandparents' wish, names will be assigned to us. But for a concept, name will not be assigned just like that. There will be a reason. So understand why the earlier is memory direct, memory indirect. Only the memory prefix is there only for these 2 addressing modes. No other will have that. You will see. Why? Because it supports only memory operands. Then, such that in the given address, there is another address. In that address, there is another address. In that address, there is a value. Same for A5 also. Same for A5 also. Assume A5 has A6, A6 has A10, A10 has value. So, the address which has the value is called direct address. The address which has another address is called, what is this? Indirect address. So, indirect address is given or direct address is given in the instruction. Which is given to ALU? Indirect is given. You are not telling directly anything. I saw it. शायद आपको पता होगा. This is direct. This is indirect. And there are many other indirections. I can't show now. Okay, in this open platform. Everybody know, right? Yes, like pointer, Shweta. Absolute. And it can just proceed like a chain, guys. It just can go on. So, if indirect address is presented in the instruction, that is indirect addressing mode. Simple, right? And second indirect addressing mode is register direct addressing mode. Guys, as there is a term direct, don't throw it in the direct category. It is not a direct addressing mode. It is indirect category. What is register direct addressing mode? So now I don't tell. You tell me. What should be the operands? What should be the operands? Registers. Register should be the operands. You need not to think much. So R1, R2. Let's say the source operands you have given two registers such that R1 has an address A1. A1 has the value. Guys, could you tell me, is A1 is direct address or indirect address? Is A1 is direct address or indirect address? Jampara, I am new to here. Can you help me about how to get courses? Jampara, this is a free series. You can just continue watching. A1 is what? Direct address, because it is having the value. Now, direct address kept in a register given as reference to ALU. See, direct address kept in a register given as reference. So, direct address kept in a register given as reference. So, what addressing mode it is? Register direct. Lakshmi, my question is A1 direct address or indirect address? How do you discriminate direct, indirect? If it has value, that is direct. If it has another address, that is indirect. So A1 has value, so that is direct. Such direct address is in the register, that is there in the instruction. So ALU got R1, in the R1 there is address, it will fetch that address, read that address, it will get the value, right? Then the third addressing mode is register indirect addressing mode. Register indirect. What is register indirect? Now, I think by this time you could have understood what it could be. In the source operands R1 and R2, R1 has some address A1, A1 has some other address A2, A2 has value. It need not to be, let's say A2 has value. Now, which is direct, which is indirect? A1 is direct address, is it? No. A1 is indirect address because it has address, another address. A2 is direct. So, A2 is direct address, A1 is indirect address. Now, you tell me, in the register of instruction, direct address is there or indirect address is there? Guys, tell me. इंस्ट्रक्शन में R1 लिखे थे. In that R1, do you have direct address or indirect address? Yeah. So R1 has indirect address. That's why it is indirect address kept in a register and given as reference to ALU. So it is register indirect. Then auto increment or auto decrement addressing mode. Auto increment or auto decrement addressing mode. What it is? Guys, due to space, I am erasing this. What is auto increment or auto decrement? Please listen carefully. I am writing some address as source. So, what should be the operands? Memory operands. Auto increment or auto decrement supports memory operands. Such that, sorry, A1 comma A4. Now, A1 has another address, A2. Sir, this becomes indirect, no? Yes, it is a indirect category only. No, sir, this becomes memory indirect, no? That is what I am telling. A1 has A2. A2 compulsorily should have value. Or, let's say, A4 is having another address A3. A3 should compulsorily have value. So, the given address A1, the effective address. What is effective address? Actual, exact, correct address of operand. So, what is effective address? Where operand is found. That is called effective address. So, A2 is effective address. A1 is specified address. What is the distance between A1 and A2? Only one address difference, right? So, A1 has A2. A2 has value. So, it's a just pointer increment. We know. It's just a matter of increment for the pointer, means address. Similarly, A4 you are given, actual address is in A3. So, it is just a matter of decrement. So, if the specified address and effective address exactly differ by only one address, that is called auto increment or auto decrement. So, these four are indirect category. We have another four also. We have three similar addressing modes, guys, under indirect category. They are relative addressing mode, based addressing mode, indexed or scaled addressing mode. What this is? Let's say I have written some addresses A1, A7. So, memory operands. Okay. Now, I want the effective address. How do I get the effective address? Means, definitely there is no chance for A1 to have the value. If A1 has the value, that becomes direct address, that becomes direct addressing mode. It is a indirect category. So, there is no chance for A1 to have the value. A1 may have something, address, let's say. So, here what we are doing is, to the specified address, if you add program counter register value to get the effective address, that is relative addressing mode. Base register value, that is based addressing mode. Index register value, that becomes indexed addressing mode. So, this is given address, this is what you are adding. Guys, I already told you, when some operand is in the form of x of y, this is equal to x plus y, isn't it? So, it is like PC of A1. PC content is added to A1, then you get the actual address, isn't it? Then what do you call X as? What do you call PC as? How much you add, or the effective address and the specified address are differ by, distant by, displaced by this much, isn't it? So what we call this as offset or displacement. What do you call it as? Offset or displacement. So these three together called as offset addressing modes or displacement addressing modes, because these are similar. What value you are adding, that is only different, but the similar operation, isn't it? And you can make a note, relative addressing mode in real time, where it will be useful means for the program sequencing. That means what to execute next, what to execute next. That sequencing of the program is because of relative addressing mode. Programs or file relocation. Whenever you transfer some data from one drive to another drive, then inside the computer, which addressing mode gets activated means based addressing mode gets activated. Indexed or scaled addressing mode, we know the concept of index. You can say array implementation. Array means, you might think, sir, if I write only C program or Java using arrays, then only index mode work. No, no, no. Guys, arrays is a data structure, you know. Even when you try to print the document, how it print? The document is divided into two-dimensional array. From the index, every data is picked and it is sent to the printer. So array implementation means it's not related to only programming. There are many real-time applications. So every time when you perform that activity, this addressing mode gets activated. Simple. And the last indirect addressing mode is implied addressing mode. Implied addressing mode. What is implied addressing mode? You are writing some opcode followed by some destination and source operands. How you are presenting the source operands? You are not presenting the source operands with its address, or in many of these forms we have discussed. Then you are giving an implication. What is an implication means? Hint, clue. You are not giving that address, that operand information directly. You are giving a hint, clue, implication about the operand, like PC and XR. PC and XR I have given. So how do you get the actual address? PC value, XR index register value. When you do AND operation, that result is the correct address. Did you understood? It's completely different way. So if the location of operand is implicit, in the instruction only location is there, but you should extract it, you should chase it. This is what you call as implied addressing mode. So altogether, how many indirect addressing modes are there? 8. Memory direct, memory indirect, sorry, not memory direct, that is absolute. Memory indirect, register indirect, auto increment or decrement, relative, based, indexed, implied. Total 8. Yeah, hello. Kinwar, Sher Singh. And what is the last way of addressing mode? Immediate addressing mode. What is immediate addressing mode? What is immediate addressing mode? If the operands, again which operands? If the source operands are values, that is immediate addressing mode. Like I am writing some opcode, like you can write even opcode also. Some destination followed by 20, 30. We know that in RTL or in the assembly language, by default any number is treated as address. So to make this as value, we have one possibility, that is suffix opcode with I. So now 20 is a value, 30 is a value. So what this I indicates? This is an immediate mode. Now guys, every instruction we know that it will have opcode followed by operands information. Along with this, there will be one bit that is called addressing mode bit. There will be one bit in the instruction also, that is addressing mode bit. Okay. And for 16-bit processor, this is very easy to understand. But now, for 16-bit processor, this mode bit is single bit. But now, for the latest processors, this doesn't work. Multi-processors or advanced processors, mode bit is not a single bit. There are around 8 bits for the mode. So we are constrained to the still 16-bit processors only for gate. So guys, don't go into details and confuse yourself. Just remember that you will have even mode, addressing mode also in the instruction. There will be addressing mode information also in the instruction with one bit or multiple bits based on the processor. Okay. So this is what addressing modes is about. Okay. Now finally, gate problems on this. They are very simple, just 5 minutes we can complete this session. Match the following, guys. Here you have left side you have statements, right side you have addressing modes. Quickly match the following. Gurpreet Singh, mode is part of opcode or not? Gurpreet, when you represent it as a mnemonic, it is a part of opcode. But when you understand in binary, mode is different, opcode is different. Okay. A of I is equal to B of J. It's what? Array access. It is related to indexed addressing. While star A plus plus, this is auto increment. Temp equal to star X. We know you are putting the value at indirection operator. So indirect addressing, isn't it? So you can say 1B, 2C, 3A. Exactly. Yeah, Shweta is giving correct answer. Saurabh, Good, good, good guys, keep going. Next question. In the absolute addressing mode, this is a 2002 gate question guys, and the earlier one is 2005 gate question. So these are all previous gate questions only. Current question. In the absolute addressing mode, read the options and tell me correct answer, please, quickly. Hemant, are you watching the session? Gautam? If so, please respond. The operand is inside the instruction. This will be immediate because operands are directly in the instruction, that is immediate. Operands means values. The address of operand is inside the instruction. Yes, this is direct or absolute. The register containing address of operand, what is this is? Register direct. And the location of operand is implicit. Implied addressing mode. So with the same options, question may change, no? So it is better to know which addressing mode is what. Yes, yes. So in the absolute addressing mode, the address of operand is inside the instruction. Good, good. Then, next question. Consider a processor with an instruction of type LW R1, 20 of R2. So, there is an instruction with some opcode and two operands, which during execution read. So, what they do, it is given. Okay. The effective address of memory location. Here what is memory location? First operand or second operand? This second operand is a memory location, right? Because it is in parenthesis. It is obtained by addition of constant 20 to contents of register R2. So, how you get effective address? Addition of constant 20 to register R2, that is what given. Then, which of the following best reflects the addressing mode implemented by this instruction for operand in memory? So, if so, what is the best addressing mode that is suitable? You tell me guys. It's very direct. I mean, it is straight question. What this 20 is called? Offset, right? What this 20 is called? Offset. In which addressing mode offset is added to the given address? Offset addressing modes. Which is offset addressing mode? Base addressing. So, base addressing is the correct answer. Okay? Yeah. Now it's the turn for you. So, quickly I will be giving you the questions. Quickly keep taking the screenshot, solve those questions and come back with the answers for next class, which is on tomorrow. This is the first question, guys. Quickly, only 5 seconds time for you. Countdown starts. 1, 2, 3, 4 and 5. Next question. Take a screenshot. 1, 2, 3, 4 and 5. Next question. Take the screenshot. Or take a snap. Those who are watching from YouTube in the computer, they can just take a snap. 1, 2, 3, 4 and 5. Right, guys. Very good. So that's all for today. I think I have taken much time of yours, but we have completed the topic. I am happy for that. So guys, try to get the green card access so that all mock tests you can take. Okay, so keep preparing. Have nice healthy food, have nice sleep. Good night everybody. See you in the next session, that is tomorrow in the same time. Till then, prep smart, score better, go Gradeup. Thank you.